Good morning, students. In this video, we will understand about the dimensions. So, what is the dimensions? The dimensions are the indices over the fundamental quantities to express any derived quantities. As we know, in the SI system, there are 7 fundamental quantities, and in these quantities, the mass, length, and time are the quantities which we are using widely to express other quantities. For example, if I am talking about the area, so the area has a formula length into breadth, right? See, this is the area, and if this is length, this is the breadth. Then we always measure the length and breadth in terms of the meter. This is called the 5 meter, this is called the 6 meter. So these two sides, they have the different name, but they have a same unit. Okay, so the area measured in terms of, this is also in a some meter square, this is also in some meter square. So the unit becomes the meter square, and the meter is the unit of length. See, so meter is a fundamental unit where the area is a derived physical quantity, and this quantity has the unit meter square. So this square becomes the dimension of the derived quantity. So the definition is the indices over any fundamental unit which express the physical quantity is known as the dimensions, right? So here I am taking some examples. The mass, length, time. Okay, the mass is a quantity, so I am making a table, quantity, and unit. Either I can write the first formula, then unit, then dimension formulas, dimensions formula. Okay, so mass has no formula, length has no formula, and time has no formula, but the unit of mass is the kilogram, the unit of length is meter, the unit of time is the second, right? The dimensions of the kilogram, because the kilogram is the mass, so dimension of the mass always written as the capital M, right? And we have to write it always in this bracket form, right? There is no indices, that means there is 1, m to the power 1. Okay, this is the mass. Mass is the unit of the, this is the meter, my mistake. This is the meter, is the unit of length. The length, dimensions of length written as the capital L in this closed bracket. The unit of time is the second. Okay, and the second expressed the time. So the dimensions of the time is written as in this form. The closed brackets are telling these are the dimension equations, means dimensions formula. The equations telling the right hand and the left hand side, right? Let's suppose if I write here the speed. Speed cannot be found directly. So the formula of the speed is length, your distance upon time. Distance upon time. The unit of distance is the unit of distance as the length, so its unit is the meter. The unit of time is the second. So meter per second. So the meter has dimension formula L, second has dimension formula T. So its dimension formula becomes, the T goes up, so becomes the T inverse, right? So the speed has dimension formula L T inverse, there is no mass, right? And the next is the velocity. As we know, the formula of the velocity is displacement upon time. Displacement upon time. And we know what is the displacement. The displacement is the shortest distance between initial and the final position. So the displacement is also a kind of length, and if it is a length, so its unit is the meter, and time has unit second. Again, if the meter and this is second, so meter has the dimension L, second goes up, and second has the dimension formula T, then T inverse, right? See, these units same and these two dimensions formula are same, but the speed and velocities are not same. So you have to understand, sometimes you may be find that there are some physical quantities, derived quantities which carry the same unit and same dimension formula, but doesn't mean that they are the same physical quantity, right? Now try to understand here. This is written L T inverse. There is the power of L is 1 and the power of T is minus 1. Again here, the power of L is 1 and the power of T is minus 1. So what is the dimensions? The dimensions are the power of fundamental quantities to express any physical quantity. Okay, so how we can find the dimensions formula? If you know about the quantity, like the velocity, like acceleration, you should know about its formula, how to find. Convert these formula into the SI unit first, and then these SI units you have to convert it into the MLT form. Okay, so the next point is the see, the displacement has unit meter, its dimension formula is only L. Now the next, I'm talking about the formula those who have which you have done in the 9th and 10th class. So that would be better for you. I'm writing next the acceleration. Everyone knows about the acceleration. And the formula of acceleration is the change in velocity upon time. So I can write here the change in velocity. Either the change in velocity, either the velocity would be same. So velocity upon the time. So this is the formula. Now tell me, what is the unit of the velocity? So the unit of the velocity is meter second inverse, a meter per second. And the time is again here, so the time has unit S, second. This second goes up. Now the unit becomes ms inverse 2. Now convert it into the dimension formula. Bracket, always written in the back bracket. Close bracket. The meter has the dimension formula L, second has the dimension formula T, but the second inverse 2, so you have to write the inverse 2. So the acceleration has dimension formula L T inverse 2. Now the next, which you know, force. Everyone know about the force, right? So the force has, what is the formula of the force? Mass into acceleration. So we always write in the form of ma. So a for here is the acceleration. So the mass has unit kilogram and acceleration has unit, where is it? It is written. Okay, it is written. That doesn't matter. You have you will not learn this. You can keep in your mind. To kilogram meter second inverse 2. Now convert it into the dimension formula. Kilogram is the mass. So write here capital M. The meter is the L. And the second is the time. So here MLT inverse 2. This MLT inverse 2 is the dimension formula of the force. Next, the momentum. How can I find the dimensions formula of new physical quantity? If you don't know the formulas, you cannot convert it into the SI unit and you cannot get the proper dimension formula. You will commit mistakes. So you have to keep the formula in your mind. If you don't know the formula, go to the book and just find it and do the practice same. Now, what is the formula of momentum? What? Yeah, its formula is mass into velocity, right? So the mass into the velocity and its unit of mass is kilogram. So see the steps. Do not do copy only. Just see the steps. Quantity and derived quantity of physical quantity. Convert it into the formula. convert into the SI units, then you can convert the dimension formula. Velocity has unit meter second inverse, right? So it is kilogram has unit mass, uh, the meter has length L, second has unit T inverse. So it has dimensional formula MLT inverse. Okay, work. So what is the formula of the work? The work is known as the force into displacement. Force F dot D I am writing, where the D is the displacement, F is the force. The force has the unit. Okay, now the force is written in a MA and this unit is a kilogram meter second inverse 2. So I am writing here kilogram meter second inverse 2. And the distance D has unit same, the meter. So kilogram meter square second inverse 2 becomes the unit of work, and its dimension formula is ml square T inverse 2. So this is the dimension formula of the work. If you are talking about the work, if you are talking about the potential energy, the kinetic energy, heat energy, any form of energy, okay, because we always know the work done always equal to the energy, and the energy has various form, and every kind of energy has same unit and has same dimensional formula. So keep note these points. The work and all kinds of energy, they have same unit and same dimensional formula. Okay, sometimes the formula to that to find the direct work is Ma, and the formula of the kinetic energy is half mv square. The formula of the potential energy is mgh. The formula of heat energy is equal to I square r dot t. Doesn't matter, but they have the same unit as written here, and the dimension formula will always be same. So you will write there at next point number 2, as I am speaking, the energy and work done and various form in the closed bracket, various form of the energy always have the same unit. Okay. Now the next is the impulse. You heard about the impulse in the class 9. So what is the impulse? The impulse has formula force into change in time. It has formula F into del T. Okay. So the formula of the force is Ma. If you know about the unit, keep convert into the unit form. So the kilogram meter second inverse 2. This is the unit of force, and the time, whether the change in time, either the time only has a unit multiplied by second. So see here, there is the plus 1 and there is minus 2. So you write there the minus 1. Kilogram meter second inverse. So you can write here kilogram, the dimension formula, right? Kilogram has unit mass, m has length, second is the time. So mlt inverse. Okay. Now the next, the momentum. ये आज से आपकी जो है लाइफ में चिपक गया है डायमेंशंस फॉर्मूला एंड दिस कन्वर्जन ऑफ क्वांटिटी टू द यूनिट एंड द डायमेंशन फॉर्मूला, ये आज से चिपक गया, कभी नहीं जाने वाला. एंड द नेक्स्ट इज द मोमेंटम. नाउ टेल मी व्हाट इज द फॉर्मूला ऑफ मोमेंटम. थोड़ा जोर से बोलो, सुनाई नहीं दे. द डायमेंशन ऑफ द formula of the momentum is mass into velocity, mv. P is equal to mv. The unit of m is the kilogram and the unit of velocity is meter second inverse. तो convert कर दो, m l t inverse. But note one point, the dimension formula of impulse, yeah, we can say the SI unit of impulse and momentum, as well as their dimensions formulas are same. So there are some physical quantities, as we did for the work and energy, to understand, as we understand about the speed and velocity, they have the same unit, they have the same the dimensions formula. So here also the momentum and impulse have the same. So maybe you will find the many quantities which have the same dimensions formula, right? So I have converted it. Now do the next. Power. So what is the formula of the power? Work done upon time. Yes. And the unit of the work is the kilogram meter square second inverse 2. Maybe you will say that, sir, you remember, that's why you convert quickly. But the time has unit second. And when this second goes up, so it becomes kilogram. I will write here. Kilogram meter square second inverse 3, right? So convert it into the dimension formula. Kilogram has unit m, meter square is called the L square, T inverse 3. So this is your dimension formula of the power, right? Now the pressure. Okay, I'm writing here about the pressure. I'm erasing, so you have to keep it very fast. You have to write it very fast. Now the next is the pressure. The pressure has formula. Will you tell me? The force upon area. Force upon area. Yes, you will say, sir, we did in the class 9 the thrust in per unit area. Actually, the thrust is called the perpendicular force. So the thrust, I'm coming in that point also. The force upon area, and force has unit kilogram meter second inverse 2, and the area has unit meter square. Area has unit meter square. Okay, as I did. So the meter got cancelled, and 1 meter to the left goes up, so it becomes kilogram meter square. I'll write it. Kilogram meter inverse second inverse 2. So I convert it into their unit, ml inverse T inverse 2. So this is the dimension formula of the pressure. Now, if I write about volume as the area first, as I told you, area has formula length into breadth, and the length has unit meter, the breadth has unit meter. So what becomes the unit meter square, and the meter is kind of length, and its dimension formula is L2. Do not read it as L square, ml inverse T. We always write ml inverse T inverse, ml inverse 2, ml inverse 3. So do not say that L square. Okay. The volume. Volume has unit length, breadth, and height. And these are the three sides. And every side has unit the meter. After producting, you will get the meter cube. So meter square is for the area here, and for the volume, you will write the meter cube, and its dimension formula is L cube. Right. Now coming to the next one. These all are the formula which you read in the class 9. So I will come in the class 10 also. One more formula is the density. The density has unit mass, the formula mass upon volume. If mass has unit kilogram and the volume has unit this meter cube, so you will write in kilogram meter inverse 3 form. Now what would be its dimension formula is ml inverse 3, because the meter has L inverse, the inverse 3. Okay, so this is the formula for the density. Now other point is the relative density. Relative density. You must have heard about this formula in the class 9 in the pressure and the pressure and the forces formula. Relative density is called the density of object upon density of water. Any type of density have the same dimensions formula. So the density of object called the mass present in per unit volume. The density of water says the mass of water present in per unit volume, and they have the same unit. They have the same dimensions formula. That's why if I write here the dimension formula of density of object and the dimension formula of the water, so both have the same, cancelled, and it has the no dimensions formula. So if no dimensions formula, so there is no need to write. Either you can write here m to the power 0, l to the power 0, t to the power 0, क्योंकि आप कटने के बाद ना तो m आता है ना l आ रहा है और ना ही t आ रही है. So इस तरह से एक चीज आपको और पता चलेगी, there are some physical quantities also there which don't have their dimensions formula. So the relative density, it shows only the how many times one quantity is greater than other, don't have the dimensions formula. So the next is these things got completed. Other thing I am writing about the next. And the next is which you did in the class 10th. Yes, current. Before current, I will write the charge. To find the charge, there is no formula because the charge has the value 1.6 into 10 to the power minus 19 coulomb, the value of a single charge. And the unit of this charge is always in the form of coulomb. We always write in a C form. Okay, the dimension formula of the C, because it is not the SI unit of that means the SI unit, but it is not a fundamental quantity. Okay, but if you are talking about the current, so current has formula charge, flow of charge in per unit time, and the symbol of charge is Q. So convert it into the unit. Coulomb is the unit of charge. Second is the unit of time. So the coulomb second inverse. And this is the unit for ampere, because the unit of current is ampere. So the ampere can be equal to coulomb second inverse, but we always write in A form. So A is the ampere. We can never convert it into the coulomb form, but you can convert the coulomb into the A and T form. See, as I know the charge has formula, you can convert it. Current has unit, the I, then charge is the product of I dot T. The current has unit ampere, that means the ampere, and the time has unit second, then ampere into second. Convert it into the dimension formula, then A, second has the T. So the dimension formula of the charge is AT and the dimension formula of the current is A. Okay, right. Electric potential. Electric potential. So the electric potential has formula work done on per unit charge. As I told you, the formula, the unit of work is kilogram meter square second inverse 2. Yes, I know its SI unit is the joule, but the fundamentals are these. And the Q is ampere into second. So you can do one thing, can cut one number, cannot cut, goes up, and it becomes the like kilogram meter square second inverse 3. Second inverse 3 because going up, and A is also going up, so you can write here the ampere inverse. Convert it into the dimensions formula. So I am converting it. Kilogram as the mass, meter as the length square, second is the T has power minus 3, and the ampere A has power minus 1. So the unit of this electric potential becomes kilogram meter square second inverse 3 A inverse, and its dimension formula is ml square T inverse 3. A inverse. You can find the electric powers unit. Now one thing is, any type of power where it is the mechanical, where it is the electrical power, they have the same unit and they have the same dimensions formula, as well as the energy, the heat energy has the same dimensions formula, right? One more thing is the resistance. Till then you should note it down. I'm coming. The resistance as I know, the resistance denoted by the R, and from famous formula, the Ohm's law gives the formula V by I, and the V has unit, I wrote there right now, as kilogram meter square second inverse 3 dot A inverse, and the current has unit only the ampere. So what would be the dimensions formula of the resistance? Now this ampere is going up, so becomes A inverse 2. So this is its an SI unit, kilogram meter square second inverse 3 A inverse 2, and you can convert it into their dimensions formula like M L as power 2 second inverse 3, that means T inverse 3 A inverse 2. So this is the dimensions formula of the resistance. You can do same for the resistivity. Okay, so I'm going to express you about the resistivity. You learned in the class 10 about the resistivity. Okay, so tell me what is the resistivity? Yes, you are going good. The resistivity is known as rho is equal to R A by L. This is the formula for the resistivity, right? And the resistance has unit this one. So you can convert it into the dimensions formula. Kilogram meter square second inverse 3 A inverse 2 into the area has unit meter square and the length has unit the meter. Okay, so 1 meter got cancelled, only the 1 meter left. 1 meter will product by this meter square, then becomes a meter cube. So it is kilogram meter cube second inverse 3 A square. You can easily convert it into their dimensions formula, and the dimensions formula are the M L cube T inverse 3 A square. Okay, so in this lecture we gave idea how to find the dimensions formula. So what is the dimensions? The dimensions are the power of fundamental units to express any other physical quantity, right? The point number 2, there are some physical quantities which have the same unit, which have the same dimensions formula. Okay, and there are some also physical quantity which don't have any dimensions formula and the unit. For example, relative density. Now try to see the book. Okay, in the in the second chapter of the physics, there are many dimensions equations, dimensions formula as mentions. So you have to note it down. Okay.